time, huh?
The last 22 hours.
Oh no, it is.
Thank you. New tradition. Okay. Welcome back. Welcome back. So continue from number 8. We are still in substitution method of solving simultaneous equation for two unknown variables. Right? Let me write out the last two. Number 8.
5x plus 4y equals -7. Negative 5x minus 2y equals 1.
Equals 1. What about the next one?
Number 9 is x minus y equals 3. 2x plus y equals 0.
Good. Okay, so while I'm solving this, someone should just help me to clean up this side and this side. Because after this, we'll be going over to the next one, which is, we can call it linear system of equation of 3 unknowns. Yeah, maybe also. Thank you. So for this first one, solutions. So which variable should we make the subject from equation 1 and 2? Number 8. Y. So let's make y the subject. If we make y the subject, we'll have 5x we have 4y equals negative 5x negative 7. Divide both sides with 4. Hence you have y equals negative 5x negative 7 all over 4. Right? So you can call this is our third equation. So now substitute the value of this in the next equation. Hence you have negative 5x negative 2 into what? Negative 5x negative 7 over 4 equals 1. You now multiply the numerator in both sides of the equation with 4. And while doing this, you have to also distribute negative 2 into this and this. Hence, you have minus 20x plus 10x plus 14 equals 4. You collect like terms. You have negative 10x equals negative 14 positive 4. Will give you negative 10, right? Good. You divide both sides with negative 10. Negative 10. Hence our x is what? 1. To get our y, we substitute the value of x in our third equation. Hence we have y equal to negative x times 1, negative 7 over 4. Hence our y is equal to what? Negative 12 over 4. That means negative 6 over 2. That means negative 3. Hence, our x comma y is, for x is what? 1. Y is what? Negative 3. So, number 9 is, let's make, which variable do you want us to make the subject from any of these equations? Which equation do you want us to make the variable the subject? Equation 1 or 2?
Equation 1.
Equation 1, yeah, because it will be very much easier for us. So which variable should we make the subject? X. X. So if you make x the subject, we'll be having, for number 9, we'll be having x equals 3 positive y. Now substitute the value of x in the next equation. Hence you have 2 into 3 plus y equals 0. You distribute 2 into this parenthesis, you have 6 plus 2y plus y equals 0. You collect like terms, you have 3y equals negative 6. You divide both sides with the coefficient of y. This side divided by 3. This side divided by 3. Hence you have that our y is equal to negative 2. Good. Now we go over to what? To system of equation. That's simultaneous equation. And this time we're having 3 different equations of 3 unknowns. So, system of equations. So, for 3 unknown variables. So this time, in the previous one, we are looking for x and y, or a and b, or m and n, 2 variables. But this time, we'll be looking for 3 different variables. Right? So, let's go. For system of equation, simultaneous equation, 3 equation of 3 unknown variables. We'll be solving this using elimination method and substitution method. Also, right? Okay. For system of equation of 3 unknown, you want to first of all look at elimination method. So for elimination method, just like what we have been doing, and what we have applied in the first, for 2 unknown variables. So this time around, we apply the same thing, but only in 3 equations. So the end still remains the same. What will you do to eliminate some variables, to make everything eliminate some variables, right? So, if you are given this 2x plus 3y minus 5z equals 8. The next one is 2x minus 2y negative 3z equals negative 3. The next one is 2x plus 5y plus 8z equals 27. So I want to solve this using elimination method. So what do you do? Solution. What do you do? So we have first equation 1, we have equation 2, we have the third equation as equation 3. So we want from equation 1 and 2, we want to eliminate x from equation 1 and 2. So to eliminate equation 1 and 2, you want to eliminate x. No, you want to eliminate y in equation 1 and 2. You want to eliminate y in equation 1 and 2. What do? Use the coefficient of z here. No, use the coefficient of y here to multiply equation 1. So, from equation 1, multiply this with what? With coefficient of y minus 2. For equation 2, multiply with coefficient of y, which is 3. If we do that, we have what? Hence, we have negative 4x plus, no, it has to be negative 6. Positive 10z equals negative 16. Good. What about the next equation? If you multiply this also, we have what? 6x minus 6y. 3 times 3, 9. 9z equals what? Negative 9. So at this point, you subtract. If you subtract, we have what? If we subtract, we have what? So, minus 16 minus 9 will give you what?
Negative 25.
Positive 7.
Ah, yeah, he's right.
We have 7, right? Okay. 10z negative 9z. 19, right? 19z. This will give you 0 when you subtract. Then what about this? Negative 4, negative 6 will give you negative 10 x. So this is another new equation. Call this equation what? Call this equation 4. this equation 4. What do we do next? We do the same, apply the same method here. You can decide to do this for, since we eliminated y here, we also need to eliminate y using equation 1 and 3. Or we can use equation 2 and 3. Right? So let's use equation 2 and 3. Hence, from equation 2, you multiply the coefficient of y here. You multiply 5. Then, for equation 3, you multiply the coefficient of y here, which is minus 2, negative 2. Hence, you have what? For equation 2, if you multiply 5, you have 10x, 10y, 15z,
minus or equals negative 15.
negative 15.
Yep.
Okay. What about the next one? You are multiplying this time with negative 2. You have negative 4x, negative 10y, negative 16z. It was negative 54. Negative 54. Right? We do what? We subtract. So this is basically what we have been doing. We did in two unknown variables. So if you subtract, we have negative 15, negative 54. Huh? 39. 39. Okay. Negative 15z, negative 16z. Z. We eliminate y. Y is out. Here we have 14x. X. We call this equation 5. Now, if you look at this equation 4 and equation 5, you can solve this using simultaneous equation for two unknown. Just apply the principle of simultaneous equation using two unknown. But since we are solving, this is the elimination method. You have to apply elimination method. Right? Now apply this separately and tell me what the value of. No. Let's complete this. Because this is our first example, right? So for this, you want to eliminate x. To eliminate x, you have to multiply equation 4 with coefficient of x here with 14. Also multiply this equation 5 with negative 10. So if we do that, we have (14) times negative 10. Huh?
Negative 100.
So we have negative 140x. We multiply by 14 again. 19 plus 14.
Plus 266.
19 times 14 will give you what?
266.
266. If you have followed to this point, thumbs up. Good. Good. So this is what we are doing. We reduce this to eliminate from the three unknown variables. We reduce this to two unknown variables. We now have this equation 4 and equation 5. And we now have something that looks like something that we can handle. We now want to solve this simultaneously using elimination method for two unknown that we have been doing. So that's what we want to apply for this and this. So we'll be seeing that this as the first equation, second equation, to get our x and z. So that's our m. If we do that, if we keep on multiplying 14 by everything that we have in our equation 4, this is equal to, this is equal to 98. What do we get? 14 times, multiply 14 by 7. 98. Okay. So this time around now, we are multiplying negative 10 with everything that we have here. Yes, we have negative 140x. We have negative 10z equals negative 390. If we subtract 98 negative 390. 488. 266 negative 10. 276. Yeah, I know that something was missing. Z. Good. If you divide both sides with coefficient of z, hence you have that z is equal to 488 over what? 276. Now divide through.
122 divided by 69.
So the simplest form is what? 122 divided by what? 69. So this is our z. So what do we now do? Since you have gotten our z,
Plug it in.
you plug this in either equation 4 or 5. So if we substitute x in, you say that z is this. Huh? How do you mean by solve this? Well, I didn't really solve this. I didn't solve the solution.
In equation 4, it should be negative 7, because we had negative 16 plus 9.
So we have a mistake somewhere.
So we have, in equation 4, it should be a negative 7, and that's where we messed up, I think.
We missed something, right? Because I'm wondering, you know, just like I said, I'm wondering how substituting this value of z, it means that if we have this as our value of z, it means that our x will also be big like this, and our y will also be big, and it will not give us a balanced equation. So whatever we are getting, the value of x, y, z, when substituted back inside this equation, three equations should keep everything balanced. That's how you know that you're correct. So you said we are saying something.
Yeah, we messed up earlier in equation 4 with negative 10x plus 19z. It should equal negative 7 instead of positive 7.
So from here,
Yes.
very far, but we can still correct it. Let's trace. Now let's do this all together to correct this. So this should be negative 7. So where can it have an impact?
Eight becomes negative 98.
So where?
98 becomes negative 98.
Okay. So hence, here will be what? $2.19.
292.
292.
Yeah.
292. So divide through. 292 divided by 276. $2.90 divided by 276.
73 over 69.
73 over 69. So 73 over 69. So this is 292. Are you sure there is no other place that this will be having an impact? These are negative 7. Is there another place that it will be having an impact? There is no other place.
No, so use equation 2.
Yeah. So we are correct. This is 73 over 69. Good. So we substitute z in either equation 4 or equation 5. Like 5. In equation 5. If we substitute the value of z in equation 5, what do we have? What's our z? Our z will be equal to, please substitute this and let me know what the value of our x will be. Please substitute this maybe in pairs in group and let me know what the value of our x will be.
Thank you, AJ.
I got 187 over 69 for x.
187
187 over 69.
over 69. Okay, good. Now we have gotten our value of x and our value of z. We now substitute all these values of x and z inside any of the equation. Just like we have been doing in elimination method. Then if we do that, we have what? What will be our y? What will be our y? Okay, what's our y?
181 over 69.
180. 181. Over what? 69. Okay, now we want to ensure to know if this is actually correct because of the error that we got earlier on. Let's substitute the value of x, y, z inside this equation. Let's know if it will be giving us to give us the same thing. Substitute in all the equation, the first equation, second equation, third equation, to know if we'll be having a balanced equation. Why we do that? Let me get ready for it.
Yep, that's what I got.
Agreed.
Is it a balanced equation?
Yes.
It's correct, right?
It's
Yeah.
Good. 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 So, let's solve the next problem. So, we are still in elimination method. So, we have to solve another one. 3x plus 2y negative z equals 11. 2x negative 3y positive z equals 7. Next one, 5x positive y negative 2z equals 12. Good. So you can see that whether it's 3 equations, 2 equations, whatever your value of all the variables are, when you substitute the value of those variables, you still have a balanced equation. So for this, let's solve this using same elimination method. X plus 2y minus 7. 2x minus 3y plus z equals 7. 5x plus y minus 2z equals 12. Okay, solution. So, solution. What is our m? We want to eliminate what do you want? Which one do you want us to eliminate?
Z.
We want us to eliminate z. So from equation 1 and 2, because this is equation, you have to be naming this. Equation 1, equation 2, and equation 3. So from equation 1 and 2, from equation 1 and 2, you add equation 1, add equation 2. We have what? Here we have 17. Right?
18.
Oh, 18. Yeah. Here we have 0. What about here? We have negative y. We have minus y. What about this? We have 5x. 5x. Good. So that means we have to eliminate also z in. We can actually use equation 1 and 2. For equation 1 and 3, or equation 2 and 3. So which one do you want us to use?
Let's do.
Equation what?
Let's do equation 2 and 3.
Okay, want us to use equation 2 and 3. That means you have to also eliminate z. So to eliminate z, you multiply this equation 2 with minus 2. Hence, if you do that, you have what?
Negative 4x.
Let's call this equation 4. If we do that, we have what? Negative 4x, positive 6y, negative 4z, negative 28, right?
No. Negative 2z.
We multiply, sorry, 2.
Yeah, 14.
So it has to be 14.
And it's negative 2z.
Where? Here.
Yeah.
Good. So for the third equation, you have to multiply with 1. It will still give you the same thing, right? You just write everything out again. Then you subtract. When we subtract, negative 14, negative 12, negative 26, negative 26. Is that correct? Good. So for z, it's out. We just eliminated z. 0. Therefore, 6y negative y.
5y.
You have 5y. Then what about this? Negative 4x, negative 5x, negative 9x, right? Plus negative 9x. Here you have equation 5. So from this, we need to be seeing this. equation 4 and equation 5, you can see that we now have two unknown variables. So we'll be applying the normal what we know how to do. The normal method of solving simultaneous equation of two unknown variables to get the value of our x and y. So if we do that, if we apply that here, we make no, we have to eliminate again. We have to eliminate because everything we have to use elimination method to make sure that once we get to substitution, we make sure that we'll be using everything has to do with substitution. But now we are making use of elimination. We have to use elimination method throughout. Exactly. So which one do you think we should eliminate? X or Y? Y? Y. Okay. So what do we do? How do we do that? How do you accomplish eliminate? How do we eliminate?
Simplify equation 4 by 5, and then add the two equations together.
Good. 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 If you multiply equation 4 by 5, you have to do it in both hand side of the equation. Hence, you'll be having this. We have 25. No, we have 25 here. 25 x minus 5. 18 times 5.
360. No, you're right, it's
90
90.
what? 90. 90. Let this be our new equation 4. Then our equation 5 is now negative 9x plus 5y. This should be y. I have y here. Equals negative 26. Negative 26. This is also our new equation. So what do? We add. When we add, we have what? 90 in negative 26. 64. 64. Where this is coming. Okay. So we just eliminated y. Y is 0. What about 25 negative 9? 16 x. Hence you have this divided by 16. This divided by 16. 16 divided by 16. Hence x is equal to what? 4. Good. Our x is 4. Now to get the value of our y, we will now have to substitute the value of 4 in the order of the equation. Let's substitute it in equation 5. If we do that, we have negative 9x. Instead of writing x, you now write 4 plus 5y equals negative 2, 6. Hence, 9 times 4 will give you 36. You have negative 36 plus 5y equals negative 2, 6. Yes, you have 5y equals 36 negative 26. 10. You have 10. You divide both sides with coefficient of y. This. As our y is what? 2. If you follow to this point, thumbs up. Good. Everyone follow. If you follow to this point. Good. Okay, so now we have gotten our x, we have gotten our y. Now we need to get our z. Is that correct? Now to get our z, what do we do? What do we do?
Plug in X and Y.
We plug in the value of x and y in our initial equation. In either equation 1, equation 2, equation 3, we plug in our value of x and y in all those equations. If we decide to plug it in equation 1, we have